All right, today we're going to talk about graphing, and if you open your book there, you're right where we're at. Let's first of all start with, and let me mention to you this phrase, standard form, okay? We're going to teach you both standard form as well as y equals. And you guys already learned the Cartesian coordinate graph system, hopefully. We'll review that kind of as we get it. But let's just really jump into it. I think that's the best way to do it, okay? First of all, we have an equation that's y equals x plus 5. You'll notice that this equation, when we're graphing, we generally have the letter y by itself, okay? At other times, we're going to be using this standard form as well. And although we don't use this form as much when we start out talking about graphing, we will use it, and we will use it even later. And there's actually an advantage of stuff being written in standard form. And we'll show you how to go between the two forms, and we'll also show you why actually standard form, if you're in the standard form of an equation, you can actually graph it very easily, okay? And all these are just the kinds of things in graphing that you learn and you build on each other. And I don't know about you, but to me, it's good stuff, okay? So that's just how it goes, all right? So, T-chart, all right? Say that with me. T-chart. So that's what we're going to use, T-chart, all right? Anybody know how many points you need to make a line?
2.
We need 2, don't we? Now, for insurance, to make sure we don't mess up our math, I mean, you guys have never messed up your math, right? You got it all right. We're going to go with 3. Just as an insurance policy, to make sure that you're doing okay, we're going to go 3. A T-chart looks like this, a T. That's profound. What we're going to do is going to put X on one side and Y on the other. We're going to put the X on the left because the X comes first in the alphabet. So X and Y. Got it? Now, you guys know, you guys have seen this before, right? Okay, and this is X or Y?
Y.
Y is the horizon, all right? I'm sorry, X is the horizon, Y is up and down, okay? Is that correct? We got it? All right, good. We're going to put our dashes, all right? I'm going to just do 3 dashes all the way around. And we all know that when you do these dashes, if you're doing the X, your dashes can't be like this. And when you do a Y, your dashes are like this. Okay? That's called not to scale. Okay? Everybody understand? Your distance from 0 to 1 on your X has to be the same distance as your 0 to 1 on the Y. Fair enough? We got to keep everything the same. Alright? So, the horizon is X, up and down is Y. Now, the X is our normal number line. If we didn't have the Y here, we would have a normal number line. Say it with me. Normal number line. Great, class. You're doing a great job. All right, now, what's the origin on the normal number line? In the middle, it's called?
0.
Right, God, you're good. Okay, now, when we go to the right on our normal number line, we have positive or negative?
Positive.
Positive. We're going forward. If we go backwards, we have?
Negative.
Negative. Good. So we indicate a dot by what's called an ordered pair. Parentheses, we put the comma in the middle. You understand that, right? Okay, good. The first number is always what letter? X. The second one is?
Y.
Mr. Grace, how do I keep that in order? Well, X comes before Y in the alphabet. Okay? It's never YX. It's always XY. So, if we have X as our normal number line, we use that as a normal number line. If we don't have the line this way, then we have something up and down. We could call it maybe the, let's see, above sea level and below sea level, right? Above sea level, like out in Colorado, you're way up sea level. They have Olympic training camps out there. Why? Because when you're high up in the air, what's Denver Broncos play in Mile High Stadium? It's harder to breathe because the air is thinner. It's tough, isn't it? Okay. I take an elevator. It's hard to breathe. Okay. All right. But that's different. All right. That's just how it is. Now we won't get into that, but it's kind of like a thermometer. Also, a thermometer. What's a thermometer? Mercury. Here is 0 degrees. Pretty cold, okay? We go up and it's positive, down and it's negative. We live in Minnesota. We're used to our weatherman from time to time saying it's going to be 14 degrees below 0. Negative, okay? We're used to that, so we have to dress for it, all right? We step outside, take a breath of cold air and our lungs feel like they freeze, or we're chipping ice that's, 10 inches thick off the windshield, it feels like, okay? Positive, negative, positive, negative. That's just a review. But we're going to graph y equals x plus 5, okay? Now, this is an equation, okay, look at this. Y equals, let's do this. 5 equals x plus 4, okay? What's x? Anybody know? What's x?
1.
Yeah, we subtract 4 from both sides. How many letters do we have?
2.
Well, we have 1 letter, right? Okay. That means when we solve equations up until this point, there's only been one answer. But now, this is called a linear equation. Linear. L-I-N-E-A-R. What's the first 4 letters of linear?
L-I-N-E-A.
Line. Okay, thank you. Line is the word in linear. It means this is linear. Do we see any powers? No, we'll learn that later. Curvy line. Cool. Okay, now, we have how many letters here though?
2.
Oh, we have 2. That means we have an infinite number of possible ordered pairs that become the answer for this problem, okay? So, here's what we do. Now, you're just going to do it automatically. Why? Because Mr. Graves said so, okay? Because I want you to. So, here's what we're going to do. We're going to let x equal 0, all right? We're always going to let x equal 0. Do you know why? 0 is the easiest number to do math with. Because 0 plus 5 is 5. 10 plus 0 is 10. Negative 74.4 plus 0 is a negative 74.4. Okay? So because of that, our math rhymes with peasy, starts with E, is easy. Yeah, oh yeah. And I know you like easy, you also like shortcut, okay? So, 0 plus 5 gives us a what for y?
5.
5, all right? Awesome. That's pretty awesome. Now, the next number we're going to use besides 0 is the next easiest number, which,
1.
right? Excellent. 1 is it, okay? So let's put a 1 here for x, all right? 1 plus 5.
6.
6. You guys are good, all right? So these actually, if you were to write them like this, would be ordered pairs of 0 and 5 and 1 and 6. We're going to graph those two, okay? So let's graph them. 0 on the x means this way. So if we're 0 on the x this way, 0 means we ain't moving anywhere, right? So we're going to stay right there. Now we go to 5, which is y, up and down. Positive or negative?
Positive.
Positive. So from here, since our x didn't move, our y moved up how many?
5.
Okay, so I've got 3. Let me just cut 5 right into there. We'll put a dot. Okay? Now, that's the first ordered pair, the first dot, first coordinate. But we can't draw a line without a second one. Okay? So a second one would be 1 and 6. So we start at the origin. This is x for 1. So x means we go either left or right, but it's positive, so we go right 1. So now we're there. All right? 6 on the y. Up or down? Up. So over 1, and we're going to go past our 5, just 1, which is right there. Okay, got it? All right, now, for the x's, we used 0. Okay, look at the x. We used 0, which gave us 5, and we went over 1 on the x, which gave us One more than 5, what?
Six.
6, okay? If we go 2 on the x, 0, 1, 2, somebody guess what about our x, our y is going to be? It's going to probably be right around 7 or 8, right? Okay? Now, 2 is a line, but in case our math is wrong, we need insurance. Let's do one more, okay? Well, I'm going to throw out an x that's going to be over here, just so we can make a coordinate over here that'll help us make our line a lot more visual than just 2 dots that close together. So let's go 1, 2, 3. Let's do -3. Okay, let's do -3 for x, okay? What's -3 plus 5?
2.
Excellent. 2, positive. So let's put that 2 there. So -3 and 2. So let's do it. Origin, -3. So we go back 3 on the x. All right. And then for the y, we go up or down 2. We go up. 1, 2. Right there. All right. Now, obviously it's not exact because Mr. Graves doesn't have a graph board. You don't have graph paper. But when you write your dot and you've done your hash marks fairly accurate, you know what will form? What's the word in linear? Line. Yeah, okay? So that means we can draw our line and we have an insurance third spot. Look at that. Look at the beauty of that, all right? That's our line. And typically, as a mathematician, we put arrows on it because it just keeps going, okay? We're good? Now, we're going to, let's take this right here, all right? See this problem right here? We're ready to graph this. We could graph this. But for this problem right here, you know what we want to do? We want to change this graph, or this equation, and we want to turn it into a standard form. You know what standard form really means? Listen to this. Standard form means x is first, y is second, equals, and then the number. Okay, let me say it again, and then we're going to do it. Now watch. When you turn something into standard form, that's what you need to do. All right? X is first, y is second, equals, and then the number. All right? Now, is x first? No. Okay? But this x, we want to put in front of the y. If we moved, and you gotta follow me because every homework problem equation is different. All right? You have to think common sense. I need to make the x first. Okay? The a just means the number. That's all that means. Okay? So here's what we're going to do. How do we make the x first in this equation? We can obliterate a -5/7 x by doing what?
1/5.
Well, actually, we obliterate it by doing the opposite. So instead of a minus, we do a plus. So we just take plus 5/7 x. And we did it on the right, so that means we have to do it what?
To the
On
left.
All right.
On the left.
All right. So 5/7 x. All right. Plus y. Bring the y down. Equals. What's the only thing left on the right hand side?
Plus 2.
Ooh, look at this. Look at the beauty of this. Let me move this so you can see it. All right. Positive 5/7 x. That means the a would be representative of what fraction? 5/7, right? Plus y. Y is there. What would b be representative? If there's no number there, it's an imaginary 1. Okay. Equals 2. Got it? All right. Now look at this. Look at the beauty of this. Yes.
Mr. Graves, or in the outline, you could just switch the y and 2.
Switch what?
Y and 2.
The y and 2?
Yeah.
Well, we'll keep the y on the left side, and we'll just drop it down. That's what we'll do, okay? Now, take a look at this. We're going to graph this. This equation kind of looks like the standard form, doesn't it? What's first? What's second?
Y.
What do you see next?
4.
Equal sign, and then you see a,
4.
yeah, and hey, I see an equal sign there. Okay, all right, you got it? You understand it? Yeah, I was talking to you. Okay, no. All right, we're good? So watch this. Look at the beauty of this. All right, we're going to graph this. You say, Mr. Ray's, what's the big deal with having, let's do 4, okay? X, Y. X, Y. So we do a T-chart. Watch this. The reason that you use the standard form is easy peasy. You know why? Because this happens every cotton picking time. This is really cool. Watch. We let each letter, we're going to let X equal 0, and we're going to let Y equal 0. And do you know what a 0 does next to a letter? It absolutely obliterates it. It's gone. Okay? Look for the 0 for the X. 0. If we do 0 for the X, we get this. You agree? Agree? The X is gone. Gone. Completely kaput. There's no X to have to deal with. So we divide both sides by what to get Y by itself?
4. 3.
Nope, step 3. Thank you. All right. Y is equal to 4/3 or 1 and 1/3. All right. So that's what we have. 1 and 1/3. Okay. Now 0 for the Y. All right. What's 0 times 3?
0.
0. X equals what? 4.
4.
Everybody see that? 0 is an easy number, and it gets rid of the term. Okay? Because the 0 on the X got rid of that, and we just solved for Y. The 0 on the Y got rid of that, and we solved for X. Oh, we didn't even have to barely think. And every time you're going to have it, and you won't have to think. And I know you guys, I know me, the less thinking the better. So 0, gone. 0, gone. So X equals 4. Okay? Watch this beauty. Now we're going to play with the axis. Okay? 0 on the X. See, X goes this way. But we're not moving anywhere, are we? No. So we're going to stay right there. Now we're going to go up and down. Okay? Do we go up or do we go down? Positive or negative?
Up.
Positive. We go up 1 and 1/3. Can you guys handle 1/3? All right? You handle that? All right. Thank you. I'm still growing up, right? Okay. Up 1 and 1/3. See it? See it? It's right there. You guys like that? Okay. Now 4 and 0. Look here. Okay. 4 on the X. We're going to go forward 4 or backward 4?
Forward.
We're going to go forward 4 right here, okay? But our Y, up and down, is it going to go anywhere?
Nope.
No. So guess what happens? When we solve these kinds of ordered pairs, all we're doing is moving one of the ways and that's it, okay? So now our line can be drawn, okay? Now, whoops. Okay, well, that's maybe 1 and 1/5, but you get the point, okay? All right, now listen. You say, Mr. Grace, that was an awful lot of explanation for you to try to convince me that the standard form makes it easy to graph, okay? Trust me, okay? When we do more problems, it will be okay. Trust me. Okay, good. All right, now, take a look here, okay? 2x plus y equals 6. Standard form, yes or no?
Yes.
Okay, let's go a little faster. And let's see if you can do it. Ready? Here's our t account. X, y. We let x equal what?
0.
0. We let y equal?
What?
0. Okay? All right. If the x is 0, what happened to 2x? What's 2 times 0?
0.
That's the beauty of 0. It's gone. What's y equal?
6.
6. Okay? right? Y is 0. If y is 0 and gone, 2x equals 6. Without putting it on the board, do you think you can figure out what
3.
x is? X is 3. All right, here we go. Watch this. Graphing. 1, 2, 3. 4, 5, 6. All right, 4, 5, 6. All right, good. 0, 6. Okay, the x is forward, backwards. Are we moving anywhere on the x? No. But the y, we're going up how many?
6.
1, 2, 3, 4, 5, 6, right there. All right. Okay, 3, 0. All right, on the x, we're moving forward 3 or backward 3?
Forward.
Forward 3, so we're right here. But our y, up and down, is it going anywhere?
No.
Not much. Listen. These kinds of problems only have movement on one line. Okay? That's the beauty and the simplicity of it. You're saying, you haven't convinced me yet, Mr. Graves. All right? The simplicity of 0, 6 is the x didn't move, so we can't go anywhere on the x, we go up 6. 3, 0 means we went 3 on the x, but when we got to the y, we didn't go up and down. Okay? The secret is these dots always lie on the axis. They're never over in these areas. Okay? They're always on the axis. That's why you have a 0. That's what makes it beautiful. Okay? And hopefully, can't promise, but I think I can promise that as you do more of them, they'll get quicker. In fact, some of you, I think even after a couple of weeks or even on a test, or if we do enough of them, you can take an equation like this and you can have it graphed easily, probably in 20 seconds. Just because you'll make your zeros and then you'll solve, 0, y is 6. 0, oh, x is 3. Put them down and then do it, all right? Now, with dots there, all right, we've got a line that runs like that, okay? 2 more, and then we'll conclude. Y equals a -2. We're going to graph that equation. There's no x. So y has a -2. All right, I did that wrong. Yeah, y x, sorry about that. Y x, okay, there we go. Y is a -2. We go down 2, we put the dot there, and this is what we have. X is 3, 1, 2, 3, we put the dot there, and this is up and down. Okay? You say, Mr. Hayes, how do we do that? Well, watch this. Y is a -2. Okay? Y is a -2 a bazillion ways all the way down. If we let x equal 0, 2, 3, -4, 7, 587, it doesn't matter. Okay? If x is 0, all right, x is 0, y is not, let me just show you, sorry, probably a wrong analogy, but it helps for us to understand that no matter what, y is -2 for this, and this is what we have, okay? So no matter where the x is at, I guess we could say at 0, all right? If x is 0, y is -2. If x is at 1, y is -2, so to speak. But the reality is, the line all the way across to -2 is where we draw our line. If it was -3, it'd be 1 down. If it was -4, it'd be 2 down, okay? And the y graphs go this way, okay? The x graphs go up and down by themselves. And we'll work on some of those so that you'll understand what they are, okay? All right, good.